Hey guys, welcome to our proofs video. Today we are going to be working with, you guessed it, proofs. And so make sure you label your heading proofs video. We have two of these, so this is proofs video. You guessed it, number one. And basically what I'm doing is I'm just going through a bunch of different types of proofs that we might see. Okay? So let's go ahead and start with this one. The first thing when we want to do a proof is we want to look at what we're talking about and see if we can get a good picture of what we're doing first, and then go ahead and tackle it. So it says 2 is congruent to 3. That's in my given portion. This is given information to me. And it's also denoted in my picture. 2 and 3 are congruent. It says prove that angle 1 and angle 3 are supplementary. Well, I'm trying to think to myself, well, 1 and 2, these two angles are supplementary. And so if that's true, then let's just say angle 2 is 50 degrees, we're just saying, for example, then angle 3 would be 50 degrees, and angle 1 would have to be 130, so it's true that 1 and 3 would be supplementary. So that's what we could do if we were trying to prove this using an example like numbers. What if we want to show it for all cases, no matter what number? Then we go ahead and join in our formal proof. Okay, so this one's kind of convenient because these first three I'm going to do have parts, and we're going to be learning basically doing parts first and slowly breaking into our own thoughts. Okay, so we start out with 2 equals, or 2 is congruent to 3. That's a given statement. And that says the measure of 2 equals the measure of 3. This is known to us as the definition of what we call congruent angles. Okay, so the definition of congruent angles. If I have congruency, I can go to equals by the definition of congruent angles. Okay, the next one. It says a blank plank or linear pair. Well, the only linear pair I see in my picture is 1 and 2, so I'm going to say that the measure of 1 and the measure, whoops, I didn't put the 1 in there, and the measure of angle 2 is a linear pair. Those two are linear pairs right there. Okay. Then it says 1 and 2 is 180. Well, that's the definition of supplementary angles. A linear pair is supplementary. Then it says 1 plus 3 equals 180 degrees. Okay. And this says steps 2 and 4. We're looking at those as well. Why they're saying we're looking at those? Notice we replaced 3 with 2. Isn't that true? And didn't we say 2 and 3 are congruent? So step C right here is a substitution step. Okay, so we subbed in the appropriate angle, which is angle 3. And then last but not least, we can say exactly what our proof statement is. Okay, so what are we going to write? We're just going to write for the last step. Whoops. And I just hit a wrong button. There we go. We got angle 1 and angle 3 are supplementary. And again, it's just what we wrote as the proof. Usually you always want to end your proof with what we're trying to prove. I mean, that kind of makes sense, right? So our big step was we substituted the 2 and the 3 with each other to do this one. Alright, next one. Alright, given 1 and 2 are supplementary, and 3 and 4 are supplementary, and 2 is equal to 3, let's prove 1 is equal to 4. Well, this is actually a theorem that we actually already learned. If 2 angles are supplementary to the same angle, then those 2 angles are congruent. This is kind of using that, but backwards. So let's go ahead and give it a look. Well, if 1 and 2 are supplementary, and 3 and 4 are supplementary, and 3 equals 2, let's try some numbers real quick. Let's use 50. If 3 is 50 degrees, 2 is 50 degrees. Well, that means this would have to be 130 to make sure they're supplementary, and this would also have to be 130 to make them supplementary. So we can see that this is easily going to work. Now we got to use our proof magic to show that it works. Make sure you're writing these proofs fully out. I know it's a lot of writing, but it is worthwhile. Alright, 1 and 2 are supplementary, 3 and 4 are supplementary. This is given information. Next, blank definition of supplementary angles. What we're actually going to write for A, and I'm going to write it over here because we have less space over there, but we're going to have angle 1, okay, plus angle 2. I did it again. I keep clicking off of it by accident. Sorry about that, guys. Angle 1 plus angle 2 equals 180. That's the definition of supplementary. And angle 3 plus the angle 4 equals 180. So those both equal 180. That's what it means, definition of supplementary angles. Next, 1 and 2 equals 3 and 4. Well, we both just said that the measure of 1 and measure 2 equals 180. The measure of 3 and the 4 equals 180. So it looks like what I'm doing is I'm substituting. So we're using substitution property. Next, we didn't fully use the given. We missed out this given piece. So we go ahead and put that given piece in right here. Why is this important? Well, now that we have this equation right here, and if 2 is equal to 3, if I got 2 out of here and 3 out of here, then I would be left with 1 equals 4. This leads us to the subtraction property. If I subtract the same angle from both sides. So basically, I'm going to go to the measure of angle 1 equals the measure of angle 4. I got rid of these two because I subtracted the same value from both sides. The measure of 2 and the measure of 3. In our example up here, we said the measure of 3 was 50 and 50. So it'd be like subtracting 50 from both sides. But we're using a generic term, so it doesn't matter what the angles are. No matter what, they will subtract from each other because they are congruent. Last but not least, we go from equals to congruency. So here we're talking about the definition of congruent angles. All right, next one. Whew. All right, this one's a little trickier. We have less things to help us out. Here in the proof, we have angle 1 is 115. So here we go, we got 115. And angle 2 is 65. Now we have our statements, but we don't have our reasons. Okay, well, statement 1 and statement 2, 3, 4, 5, 6, we got to come up with. Before we do that, we want to prove that L and M are parallel. Well, let's think about this. 115 plus 65 is 180. These two angles are going to add up to 180. Angle 1 and 2 are also consecutive interior angles. So I believe if we use our rule that if these are supplementary, then we can prove that these two are parallel by using the converse of consecutive interior angles theorem. And that's shorthand for theorem. So that's kind of our goal. So let's go ahead and get started. Step 1, measure 1 equals 115. That was given. Step 2, that was also given. So we could have done that in one step, but they decided to do it to 2. That's okay. It just makes me feel better about myself because I'm filling in more. 115 plus 65 equals 180 degrees. What's the reasoning here? Well, we're basically going ahead and we're just going to set up an equation and we're just adding, okay? This isn't addition property or anything like that, okay? What this is we're just showing that these two pieces add to each other, okay? So, do we really have necessarily a rule for this? Yes. We would call it angle addition postulate. Okay, we're adding two angles to make up another angle. So we call it angle addition postulate. Okay, so it's formulated off of that. Next, 1 and 2 equals 180. Well, I'm just subbing out, instead of 115, I'm saying 1. Instead of 65, I'm saying 2. So we're talking about substitution property. 1 and 2 are supplementary. That's easy. That's just definition of supplementary angles. And last but not least, M is parallel to N. And this is the most important piece, and this is that theorem that we used, or we said right here, and it's just that the converse of consecutive interior angles theorem. Okay, and that's our last piece. So we were able to do it all. Again, I had no angle addition postulate, definition of supplementary triangles, and the converse of consecutive interior angles. Last one. All right, no given, no statements, nothing here. What are we trying to do? I know A and B are parallel, so let's go ahead and draw that. We know 2 and 3 are congruent. 2 and 3 are congruent. Okay. If I can show that something, so I can prove that C and D are congruent. Well, if I can show that if I can show that 4 and 3 add to 180, I could show interior angles, consecutive interior angles, and I can prove that C and D are parallel. So I'm thinking maybe I can do this with CIA. I'm thinking that might work. Also, what might work, given C and D, it has to be working off of the transversal B or A. If I can prove that 2 and 1 are congruent by corresponding angles, I could also prove it. So we have a couple different ones. So I'm actually going to pick the corresponding angle direction. So let's go ahead and get started. So we're going to start off with my statements and my reasons. Okay? Statement 1. I like to always just do all my given at once. A is parallel to B. Angle 2 is congruent to angle 3. Why is this? Let's do a different color. Over here, why is this? It's given. Okay? Next, I want to show, this is what I want to show. I want to show 1 and 2 are congruent. If I can show that, then I can use the converse of the corresponding angles theorem. So what could I do? Alright, well, how can I show that's congruent? I know 2 and 3 are congruent, but hey, isn't 1 and 3 congruent because parallel lines A and B? 1 and 3 are congruent because of alternate interior angles. So I can show that angle 1 is congruent to angle 3. And I know this, back to my other color, I know this because of my alternate interior angles theorem. Okay, notice how I'm using the normal theorem to prove angles, but when I use the converse, I'm proving parallel lines. So they go back and forth. Okay, so there we go. 2 and 3 are congruent. Or sorry, 1 and 3 are congruent. Now, okay, this is where it gets a little tricky. Number 3, I want to show that the angles are congruent. I'm going to erase this in case we got a little confused here. Let's just start back from scratch. So again, my original statement is that this is congruent to this, and I just showed that 1 is congruent to 3. Well, if 1 was 50 degrees, that means 3 would be 50 degrees, which means 2 is 50 degrees. So what I can do is, I can substitute. So what I'm going to do here is I'm going to just say, well, heck, 1 is then actually congruent to angle 2. Why? Because of substitution. Okay? So step 3, we have substitution. This is a great proof. Okay? So substitution. Next, this is cool. I'm going straight for the gut. Here we go. Next, I'm going to go ahead and give you my proof. C is parallel to D. Why do I know that? Well, 1 and 2 are corresponding angles. And if corresponding angles are congruent, then we have parallel lines. Okay, so step 4 is the converse of corresponding angles theorem. Okay, and there it is. We're all set. We're all done. This gives me my proof and my theorem, why it is. Okay, what would be a good idea to study these? Here's a nice list. I'll probably have printed out for you on block day. But this is basically a list of every single definition and postulate that you are going to learn basically in this whole year. Yes, this is 1 out of 11. Okay? Look at all of this stuff. The cool part is we've already seen a lot of this already. Okay? But a lot of it we have not. Is there a lot here? I hope I'm freaking some of you out a little bit. But we have a lot to learn. A lot to go over. and a lot to remember. Okay? So that means if I were you, I would really make sure I'm studying, getting used to the ones that we have now, because it's only going to get more and more complex. You're probably wondering, like, oh my gosh, they're still going. Yes, they are. And the crazy thing is, we are going to use all of those. Okay? And there it is. That's the last one right there. Equation of a circle is the very end of our list. Okay? So, a lot to do. Anyways, I hope you enjoyed the video. I know it's a little long, but proofs are some work. And the main part of the work is knowing this information. Ciao.